Hello everyone, welcome to the first technical lecture of IC 141. This is Product Realization Technology lecture. Alright, so in the previous lecture we discussed a few basic things about the outline of the course, the syllabus of the course, and also evaluation scheme and so on. Now from this lecture onwards I'm going to start talking about a few technical things, the content of the course as such. Still, this one is an introductory lecture, which basically means that I'm going to tell you what are manufacturing processes and what is the definition of material. So the course is designed for someone who just came out of school and is doing first year of engineering, right? Like all of you. All right, so this is where we left off in our previous lecture, right? What are materials? So materials are basically, material can be defined in many ways. Everything that is around us, everything is a material. Even sometimes somebody will give you a book to read and say, this is reading material. If you go and get some, some dress tailored, they will say this is dress material. But here we are talking about materials that are used for manufacturing purposes. Okay, so manufacturing purposes means there should be some material that can be, that you can touch, that you can feel, that you can mold, you can provide it a shape, you can also process it. So for example, if you think of wood, you can do carpentry with the wood. So you can cut it, you can slice it, you can make powder. There are many materials which are used in powder form, or there are some materials that are available in the powder form, and then you make certain shapes out of it. You can think of clay, you can think of many natural materials as well. So all of these things that we use for manufacturing purposes, those are the materials that are important for this particular course. All right, so what is manufacturing? Manufacturing is just simply making something, the processes that are involved in making something. What is that something? So we discussed also in the previous lecture, we make a product. Product can be anything. Nowadays there are also many products such as software. They are not tangible products, and those products will not be covered in this particular course. Also, they are also products, right? But if you want to make, say, a part of a certain machine, or if you want to make furniture, or you want to make some electronic goods, all of these things come under manufacturing of tangible things, manufacturing of products that many of them you utilize in your daily life, right? So this is what we call manufacturing here. This is what we are going to learn in this particular course. Now, what do I mean by large scale structures or large quantities? So I have written here, manufacturing is about making large scale structures and large quantities. So large scale structures, don't get confused. We are not talking about, like, the structures don't need to be several meters in dimensions. Large scale means something that you can hold in your hand, something that is not micro nano scale, because, and that is why I wrote large scale structures, because nano materials, we will probably come to it at some point, that nano scale nowadays things are very, very small, and some of the electronic devices utilize those very small components. We can also call them manufacturing, but that's a different area altogether. What we are going to discuss in this particular course is going to be large scale, means something you can hold in your hand, that kind of structure. How about large quantities? So irrespective of what is the size, dimension, type of your product, when we talk about manufacturing per se, when we talk about industrial manufacturing, we talk about making large quantities. So the quantities should not be 1 or 2 or 5. You should have a process that is capable of making hundreds of structures of the same type, exact same type, and you should be able to get the exact same product when you make 100 of them, right? Maybe there is a little bit of variation that is possible, a little bit what we will call tolerance or error, that is possible, but you should have a process which is capable of making hundreds of structures of the same type. That process then is an industrial manufacturing process. Okay, but we are going to start step by step. So we will first learn about what are the materials that can be used, what are the different types and classes of materials. In the next few lectures, I'll discuss each one of those materials, each type of materials. Then we will discuss each type of manufacturing process. What are the possibilities? What are the things we can do with the materials? And then ultimately we will come to the idea of a product. The idea of a product that involves not 1 or 2, but maybe several different types of materials and several different types of manufacturing processes. All right, so I will already start with an example. Okay, think of some tools. So you know what are tools. In fact, if you want to learn this course, this is the first thing. This is sort of your first assignment. Here is a picture of several tools. These tools can be used in the workshop. Also, some of them are used in your house. See, there is a hammer there. Some of them are used for farming. So there are many things, many applications of tools. So this is your first, task. What you should do, try to find out these tools in your house. And if not in your house, go to a nearby workshop, go to a nearby farm somewhere. You will find these tools and find out what are their names. Just try to hold them in your hands. Also learn their names in your local language, because the various tools may have different names in local languages. So try to learn the local language, the name in your mother tongue, and then you just hold these, just to see how heavy it is, just see how convenient it is to use it. Just think about it. Do you think there can be any design improvement? Let's say if the hammer is too heavy, or you think that the head is too heavy and you have to use too much force, can you actually come up with a design improvement? Okay, even if you don't think of design improvement at this point, just try to go and find these tools. Because if you want to learn anything about manufacturing, if you want to learn anything about product workshop, then tools are the first things that you need to get comfortable with. All right, so this is an example, a lot of tools. Now what do we do with these tools? Now if I ask you to pick one of these tools and think about how it is made, so how it is manufactured. Now remember, we use tools for manufacturing, but first we also need to manufacture the tool itself, right? So how do you make one of these tools? You can pick one. Okay, what is the information you will require before manufacturing something? First of all, what should be the size? So because here you have already some pictures given, but if not, if I just tell you randomly make a hammer, then in that case you will need to know what should be the dimension, what should be the size of that hammer. All right, what should be the capacity? Now in the case of capacity, capacity is also defined differently for different purposes. You can, for example, if it is a larger machine, if it's a farming equipment, for example, and you are separating grains with it, using that equipment. In that case, you will need to know what is the quantity of grains, 1 kilograms or 100 kilograms. But no, that is what is meant by capacity. In the case of a hammer, in the case of any smaller tool or smaller equipment, the capacity is mostly defined by, how much force, what is the application, for what purpose do you need to use that thing, whatever you're manufacturing. So that is the second information that you need. You will also need to know what kind of power requirements, AC or DC, what should be the voltage requirements, what should be the horsepower for the large scale machinery and so on. So these are some of the things. Then finally, you will also need to know some aesthetic details. Now, aesthetic details does not mean how beautiful your product should look. That also is a part of it, but sometimes there are tiny little things. For example, when you talk about a hammer, it should be, it should be held tightly in your hands. You should not have a hammer that slips out of your hand, because that can lead to accidents. Even forget about a hammer, when you use a pen, sometimes I know that there are some pens which do not have those little threads in them, so when you write with them, they slip, or your finger slips on top of it. So those kind of things also come under design, under aesthetics. So all of these things, sometimes also finishing, polishing, coating. If you paint something, for example, this hammer, you can see it has some blue color on it. Now, when you paint a hammer blue, it's not just for making it look better, but also to protect it from rusting. So all of these kind of details also you will need before manufacturing. Okay, what else? Think of the most important thing. You also need to know what materials you're going to use, right? Are you going to make this hammer out of plastic? The top part of the hammer especially? And if yes, which type of plastic are you going to use, right? Or are you going to make it out of cement or iron or gold? So this is the very first decision that you need to take. What are the materials that are going to be used for making your product, right? Okay. Now, hammer is the example I've already given you, right? You see that the top part, in this particular case, it looks like iron, cast iron. Now, iron also has different types, and iron-based alloys, steel particularly, also has many different types We are going to learn all of them in this course. Okay, anyway, this looks more like iron, right? The bottom part, what do you think? This is made of wood. In this particular picture at least, this is made of wood. Now if you see this other tool, it has some pinkish color handle which has a plastic coating on it. So plastic is another material. Now how many materials you have seen here? 3 materials you have already seen. Now think about what are the other things. The other tools, this is cast iron, but there is also a more silvery looking metal, right, in the leftmost tool. This one, right? So it may be iron, it may not be iron. It may be steel, it may be a certain type of steel. Okay, so as I said that there are different types of steels which are defined primarily by the carbon content in them, because steel is made of iron and carbon, but there are also certain other additives, and we will discuss in detail what are different types of steel. Anyway, the point here is there is one more thing that you should notice. The first one, hammer, had iron and wood, and these two things were joined together. So that is the something that is made of two different materials. But the leftmost tool, if you see, there is no joint between the top and the bottom part. It is one piece, right? So some of these tools are one piece, and some of them have joints. What does that mean? There may be some manufacturing processes that give you the product without any joints, right? And some of them require assembly or joining. So you make different parts separately and then join them together. And yes, exactly, this is what we mean by different manufacturing operations. Some operations or processes will give you certain type of structure, and that may only be compatible with certain types of materials, may not be compatible with wood, for example. But in the case of metals, maybe you can make a single structure without any joints, and then joining operations are studied separately. How do you join two metals together? How do you join a metal and wood? How do you join a metal and plastic, or ceramic and plastic, or ceramic and metal? All of these things we are going to learn in this course. These things come under this general umbrella of manufacturing processes. Okay, so the decisions that we were making, materials, manufacturing process, and very importantly, cost. So you will say that why cost is important. You know, now in your school, when you learn about fundamental things, when you learn about physics, math, material science, all of these things, you think that you never think about the cost. But when you're actually making a product, let's say you make an amazing hammer, but you're selling it for 1 lakh rupees. Who's going to buy it? Why are you selling it for 1 lakh rupees? Maybe because your manufacturing process itself is so costly that you cannot sell it for anything cheaper. Otherwise, you will go into losses. So in that case, you also need to understand what should be the optimum cost for any product. And whenever we are working with manufacturing processes or industrial manufacturing processes, we are always trying to minimize the cost while not compromising the quality. So this is another decision that needs to be made. Okay, and then of course, if we want to make several such hammers, then the suitability for bulk production, for large scale production, is something that we need to evaluate. So these are the fundamental things. These are the first thing that will come to your mind when you think of making any structure, manufacturing anything. Okay, so now we learned about these materials. Just general things we learned about, like all materials, right? But I told you there are different types of materials. So how do we classify materials? There will be a separate course on material science where you will learn the details of it. But in general, if you think about how do we classify materials? So one very simple way to classify different materials is crystalline or amorphous. Now, these are the terms I'm sure you have learned also in your school. And maybe there are a few fundamental things that you know about crystalline structures. What are crystalline structures? When you have these nicely organized or ordered atoms in any certain material, that is what is known as a crystal structure. There are different types of crystal structures, but let's not go into the details of individual crystal structures. We just want to see how crystalline is different from amorphous. So again, amorphous also, you know that, well, the atoms are randomly oriented. So there is no order in these materials. Now, if I say it in more, correct terms, so to say, then amorphous materials have different bond lengths. So you know what is the bond length, right? The length of the bond between any two atoms, whatever is the type of bond. That's not important right now. Let's say covalent bond, let's say ionic bond. But there is a certain bond length. Now in the case of crystal structure, these are very, very well defined bond lengths in all directions, and that is why we have this crystal structure. In the case of amorphous material, let's say atoms are randomly distributed. Maybe there are two bond lengths which are same somewhere in that material, but they are not necessarily next to each other. They may be, all of these things may be randomly oriented. So atoms are not organized. That is your amorphous material. Now these two cases that I have shown here, these are truly amorphous and truly crystalline materials. And the properties of amorphous crystalline you can again revise from your school days, that crystalline materials will break in a along a certain plane, while amorphous materials will shatter on breaking. And there are also electrical, mechanical, several properties. Now for manufacturing purposes, however, we need to understand that we are not going to, especially when we are making a large scale structures, we are never going to have a perfect crystal or a perfectly amorphous material, except extremely few exceptions are there. But for typical manufacturing purposes, you're often going to have what is a mixture of crystalline and amorphous material. So you will call it crystalline, but it will actually have some pockets of amorphous regions. So for all practical purposes, for all manufacturing purposes, your materials are not single crystals for sure. Okay, so there are also other materials which again right now we will not go into the details, which are known as, they're neither amorphous nor crystalline, or they're crystalline in certain region, amorphous in certain regions, but these are some other types of materials. What is important for us is what I just said, that are your are your metals, for example, if you use metals for manufacturing, are they single crystals? The answer is no. For all practical manufacturing purposes, you have, even if you have crystalline materials, let's say even if it is a completely crystalline material, still it's not a single crystal. There are many small little crystals which are oriented, randomly oriented, with respect to each other, and such materials are known as polycrystalline materials. So as the name itself suggests, it has crystal structure but several crystals randomly oriented. And of course during practical applications you will have polycrystalline material with some defects or pockets of amorphous, the same material but in the amorphous form. And these pockets we will, because we want to have a crystalline material, these pockets we are going to call as defects. Okay, now defects can also be air bubbles trapped during manufacturing. The answer, yes. The defects can also be because of some impurities in your material. The answer is yes. But when you have, let's say, a big piece of iron, a big block of iron, if I give to you, that is, despite the fact that iron is a crystalline material, as a metal it's crystalline, that block of iron will contain a lot of defects, which will be either amorphous or amorphous regions or air pockets or many other things that are caused during your manufacturing process. So now let me define quickly what is this term defects. You have learned defects in your semiconductor physics. So the defects that you probably learned about are these atomic level defects. So point defects, for example. Those are defects, but they are not at product level. So we always, when we talk about defects, there are different levels. For example, if you buy some mobile phone and that phone does not work, then what do you say? You say this is a defective product. Are you talking about the point defects that you learned in semiconductor physics? The answer is no. This is just a completely different level of defect. This is the defect that is at product level. If a product does not function as we expect it to, then we call it a defective product. So these are the product level defects. Second level would be manufacturing level. So what are manufacturing defects? That is what we are going to learn a lot in this course. When we perform a certain manufacturing process and we expect something which does not really come out as we expected, you will see when you pour really hot metal, for example, into some cast, then it needs to be done very, very carefully, otherwise there will be bubbles trapped, because as soon as your metal cools down, the shape will be frozen. So if there is an air bubble inside it, well, that bubble is then trapped. Those kind of defects are known as manufacturing defects. And the third one is what you have already learned, the material level defects. That's where you talk about point defect, line defect, surface defects. So there are dislocations and grain boundary, all of these things which for now are not too important for us. So we are going to focus on manufacturing process related defects in this particular course. Acha. Can you think about it? This is again something for you. Are there any advantages of using crystalline materials? So crystalline compared to amorphous. Are there any advantages of using crystalline materials for making anything? All right.